All right, so now we're going to move on to part two of the concept 7.3. And I split this into two parts. So we'll be doing subtracting next week. So I'm not trying to overwhelm you. I just want to make sure you understand we're now moving on to adding rational expressions with unlike denominators. So this is going to be a little bit different. So let's start with even talking about, if you can see on the screen, it says adding with unlike denominators. And I have a couple from elementary school. And I tend to do that in class. You all know I do that with you. Just to kind of give you a quick introduction of what this looks like back without variables. So first of all, I want to make sure that you remind yourself that LCD stands for least common denominator. And when you are finding the least common denominator, that's how we're going to be able to get our denominators of our two fractions to be the same. Because remember, when you add and subtract fractions, you have to have the same denominator. So a least common denominator is the smallest number that two numbers can go into. So I think the easiest way to explain is to kind of look at our example for part A. So if you were going to add by hand, not on a calculator, you were going to add 1/2 plus 3/8. I'm going to blow this up. What we would do is we need to figure out what is the smallest number that 2 and 8 both divide into. Well, since 2 goes into 8, our least common denominator, so if I write out to the side, our LCD here is going to be 8. So what that means is we have to ask ourselves, what can I do to this 1/2 fraction to get it to have a denominator of 8? So I'm going to multiply 1/2 by 4, and then whatever you do to the bottom, you do to the top. So I'm going to multiply 4 times 1 on the top and get 4. On the bottom, 4 times 2 is 8. So what we now have is we have denominators that are the same. So remember, the denominator stays the same. You cannot do any simplifying until after you add. So 4 plus 3 is 7. Now, since 7 and 8 do not have any common factors, you're finished. Okay? Now let's take a look at example B. Now, you'll notice it's very similar to A in that we have 1/2, but this time we have plus 3 over 7. Now, 2 and 7, 2 does not go into 7 like it did over here for A, where we had 2 go into 8. So 2 goes into 7 no times. So we have to ask ourselves, what's the smallest number that 2 and 7 can both go into? And so this time our LCD would be 14. So to do that, I'm going to multiply the first fraction. We're going to multiply by 7 over 7 because that would give us a fraction of 7/14. Now remember, 1/2 and 7/14 are the same value. They're both equal to a half. And then for 3/7, to get a 14 in the denominator, I would multiply by 2, but whatever you do to the bottom, you do to the top. And so you're going to get 6 over 14. Now, the denominators are the same. Leave them the same. Otherwise, you cannot add the top. So 7 plus 6 is 13. Now, once again, that does not simplify because there are no common factors. All right, now that we reviewed with some kind of elementary school examples of just numbers, let's take a look at example number 1. Remember, we're just going to do adding right now. So if you notice, the denominators are x squared and 8x, and obviously those are not the same like what you worked with last week. So if we think about what would be our least common denominator, this is where students sometimes struggle. So I need you to understand that right now, this denominator has an 8 times x, and this has an x squared. So what I'm going to do is I'm going to multiply this fraction by 8 on the bottom. And the reason I'm going to do that is because on the bottom now I get 8x squared. Now whatever you do at the bottom, you have to do the top. So in the top we have 8 times 4x, which is 32x. Okay? Now, for our second fraction, right now it says 8x, and the least common denominator could be 8x squared. So in order for this denominator right here, if you can see my mouse, to be 8x squared, we need to multiply by x. So once again, I'm going to do my denominator first. So we have 8x squared, and then 20 times x is 20x. So what happens now is we now have these denominators here that are exactly the same. So immediately, I need you to understand, kind of like last section, last week, I'm going to keep that denominator the same. I cannot simplify, I cannot cancel anything, and some of you are trying to do that. So on the top, I'm going to add 32x and 20x. I can add those because I have that same denominator. So I'm going to add 32 and 20, and that's going to give me 52x all over 8x squared. All right, and then some of you were trying to leave your final answer this way, but we cannot because we know that 52 and 8, well, they're both even, so we know 2 would go into them. But actually, the biggest number that would go into both those would be 4. So 8 divided by 4 is 2, and 52 divided by 4 would be 13. So I would have 13 over 2 for sure, and then x goes into itself once, and we would be left with an x. So your final answer would be 13 all over 2x. All right, so let's go on to example 2. And once again, we do not have a common denominator. So once again, we want to look for our least common denominator. So I kind of look, even though 10x squared and 25x are monomials, I kind of look at the coefficient, the 10 and the 25, a little separately. So let's think. 10 does not go into 25. So the smallest number that 10 and 25 go into would be 50. And then the smallest kind of term that x squared and x go into would be x squared. So you can't use x because this one right here already has an x squared, if that helps a little bit of why I'm using x squared. Okay, so what I'm going to do is I'm going to multiply this first fraction by 5 over 5. And what that's going to give me is 5 times 10x squared is 50x squared, and 5 times 3 is 15. And then over here, we already have 25x, but I need to figure out what to multiply by to get 50x squared. So I'm going to multiply that by a 2x. And whatever you do to the bottom, you do to the top. So the denominator, 25x times 2x, is 50x squared. And in the top, I have 7 times 2x, which is 14x. Okay. Now, once again, if I double check my work, I'm just going to kind of do squigglies here. The denominator is the same. You must now add the top. So the denominator stays the same. It's our least common denominator of the two fractions. And on the top, we would have 15 plus 14x. Now, there's nothing that can be simplified in the top. Like I can't factor anything out of the binomial. So I'm going to rewrite this just in order because that's what we math teachers do. We make it look pretty. So your final answer here would be 14x plus 15 all over 50x squared. All right, so let's go to the back side of your notes, and we're going to do a couple more examples together. If you want to try this first one on your own, push pause because you will be doing some of these kind of for your assignment on your own. So for number 3, we have a denominator of x, and the other fraction has a denominator of 3x. So I hope this one seems a little bit easier, but the LCD, in this case, would be 3x. So we're going to multiply the first fraction by 3 on the top over 3 on the bottom. So we have a 3x on the bottom. Now I'm going to do this kind of the long way instead of in my head to show you. So that would be 3 times the quantity of x plus 1. And then over here, We have x minus 3. We didn't have to do anything to this second fraction, okay? So what I'm going to do is I'm going to go ahead and distribute first. So I'm going to have 3x plus 3 all over 3x plus x minus 3 all over 3x. Now, in past years, students start to cancel right away. And I'm like, no, you haven't done anything yet. So right now, I am going to write 3x because I have to have a common denominator. So what I'm going to do is I'm going to add the numerator of the first fraction and the numerator of the second fraction, okay? And what that gives me is we have a 3x and an x, which is 4x. And we have 3 minus 3, which those cancel. So when we look at our final, what we're left with, we have 4x over 3x. Well, the x's cancel. So your final answer to this is 4/3. All right, on to number 4. And this one might look a little intimidating, but I promise you will be fine. So this one is a little funky because our denominator of x plus 8, you're thinking no big deal. But then we have this denominator right here. And a lot of people are like, well, how am I supposed to find the common denominator? So I'm going to tell you that factoring is going to come important. So what we're going to do is we're going to factor this x squared plus 11x plus 24. And by now, a lot of you are really good at factoring. So what multiplies together to give me 24 and adds to give me 11? Well, that would be a positive 8 and a positive 3. Now, it is no coincidence, y'all, that this second fraction right here has an x plus 8 binomial and the first one does. So our LCD literally would be an x plus 8 times an x plus 3. Now, we already have an x plus 8 over here, and we have that factor here. So we just need to multiply this first fraction by x plus 3. So whatever you do to the bottom, you do to the top. Now, I know this is a little weird, so if you need to push pause and kind of think about what I'm doing. So right now, my first fraction is going to say 7 times, I'm just writing that backwards to make it easier, 7 times x plus 3. The denominator would be this x plus 3 times this x plus 8. I am not going to actually like FOIL that out or anything. Don't worry about that. You now can see that denominator is x plus 3 times x plus 8. Now the second fraction, we're actually not going to have to do anything to because the 35 is on top. And when we factored this right here, we got x plus 8 all over x plus 3. So as you can see, the denominator is the same. Now, people want to start like doing weird stuff, but you haven't even really done anything yet because now we need to add. So on the top, I'm going to go ahead and distribute. I'm going to get 7x plus 21, and then I'm going to add that to this 35. And then our denominator, because they're now the same, we are going to write that addition over the same denominator. Okay, now let's add. So we're going to have 7x and 21 plus 35 is 56. So we have now actually completed the addition. Now what happens is we're now going to have to factor the numerator. So you're not finished. Yes, you added, but remember, once you add, you cannot cancel. Notice I haven't canceled anything from the top and bottom until I am done. I added. Now I'm going to factor out a 7 from 7x plus 56, and I'm left with x plus 8 on the top, all over my original common denominator. Now what's lovely about this, as you can tell, we have that x plus 8 on the top, which will cancel with the x plus 8 on the bottom. So your final answer would be 7 all over x plus 3.